There you go.
Thank you so much.
Okay. So I'm hoping I can assume that most of you have your book, and or at least a notepad. On the urinary system, the portions that I would like you to pay special attention to, an outline. Okay, and this outline will be due next week, next Monday, midnight. Okay. It starts with the kidneys. Of course, we're going to read that. I'm going to sort of skim a couple of diagrams, but I'm not going to do anything with them. The internal gross anatomy of the kidney. Skip an application or clinical application. I'm not concerned with vasculature and nerve supply at this point. So now I'm on a page that has a kidney and has sort of a flow chart. The kidney diagram is very useful. The flow chart, don't memorize that flow chart. I'm going to use most of it, but I'm not going to include all the items that are on that flow chart.
The blood flow chart, right?
The blood flow chart, yes. Okay. The one that's sort of diagrammatic. It's not very useful, and you'll get whatever you need out of the lecture for that. Reading on, underneath it, I come to microscopic anatomy. And this time, although we have not been doing microscopic anatomy, I want you to begin doing it with the kidney. So yes, read microscopic anatomy of the kidneys, mechanisms of production, nephron structure. First time through, you may feel you're getting in over your head. You may want to wait and listen to the lecture first before you dive right into this. The next page is a nice diagram, but you can skip the diagram. It actually has 4 diagrams on one page. Okay, that's the page I'm looking at. It's figure 24-6. Okay. The next page, the diagram showing a nephron. That's the ball and the curly ducts moving away from it. That's important. However, the right-hand side of the diagram showing the various cell structures is not. Continue reading at the bottom of the page. Don't miss that it's got a few lines down there. The next page, numbers 1 through 4 are very important. 1 starts with proximal convoluted tubule, just to be sure we're on the right page here. The 2 diagrams on that page, very important. Not necessarily that I'm going to ask a ton of questions out of them, but for your understanding of what you're reading. Classes of nephrons, yes. And when you feel that you can tackle it, figure 24-9. Okay. It's not difficult. You just have to just be calm, go through it, do the reading, come back maybe, and then it just all falls into place. 24-9. On the next page, blood vessels. I'm going to ask you not to outline those. I'll give you those as needed in the lecture. Juxtaglomerular complex, no. The ureters, the reading is minor, and I'd like you to do it. But here you don't do microscopic anatomy. So you'll find that it's just a couple of paragraphs. The urinary bladder, the first 4 paragraphs, until you get to vessels and nerves, and then don't do that. And microscopic anatomy, no, we're not going to do it here. The only place we're doing that microscopic anatomy was back a few pages where I asked you for it. Okay. Come to urethra, and above it, you can put the word stop. That's it. That's sufficient. Okay. If you look at the rest of the chapter, it's into disorders and the urinary system throughout life, and not gross anatomy. Okay, put this away. Okay, any questions? Okay, I've got a few things. The assignments that were due last night was the practice test. I gave you 2 practice tests, and I said that you only needed to do 1. I think that everybody that did 1 did them both. The numbers are there. I can actually look, of course, and see who did it, and I will be soon. But they just came in. And the other assignment was for chapter 23. 8 people did not do a test, a practice test. Now, the practice test is the simplest thing in the world to get out of the way. I mean, just to get credit, all you have to do is sign into the test, answer 1 question, even if it's wrong, and submit the test. And Canvas puts you down as having taken the test. And that would have satisfied that, but 8 people couldn't even bring themselves to do that. I'm sorry. 8 people also couldn't bring themselves to give me chapter 23 outline. I want these things right away. I really want them right away. I'm not here, and you aren't either, at least when we started out. Neither of us are here to have you not do well. I want you to do well. I know that chapter outlines can be tedious, but I know that the grades, ever since we've instituted them, have gone up. And I want you to see you do well. And if it's 8 people that haven't done the outline and haven't also done either of the practice tests, somebody's getting way behind. And, you know, we're almost halfway through this. And I know you don't want to waste your time. And I don't want to harp or anything like that. That's not my intention. Is to try to encourage you, if that's the word, or push you if I have to. And for most of you, I don't have to do anything to get your best grade. Okay. I'm not just going to one-side this. If you want to say anything, go ahead. Okay, get me the chapter 23s if you didn't do it. That's the most important chapter. That is going to be the killer, if I can call it that, on the second lecture examination. Please get it done for your own sake. You can't do these things at the last minute. Oh, you think you can? Well, prove me wrong. Okay, and okay, now I'm starting to harp, so now I'm going to quit. I have also decided unilaterally, sorry, you don't get a vote in this one. My job is, as I said, to help you, to present the material and help you absorb the material and get the best that you can going forward to the next class or to even your career. Well, I don't feel that even the many of the very good self-motivated starters, self-starters, I don't even feel that they're going to be ready for practicum 2. I don't think right now anybody's going to be ready for practicum 2 without a little bit more time. Okay, and I think a lot of that is because we spent so much time getting ready for the lecture examination and putting that first. That's the way I do it too. And then I get behind on the other and I got to catch up. But we got people, as I said, that really have to catch up. And we're not going to wait for them much longer. We just cannot. We've got to go ahead. The practicum was scheduled for Tuesday, the 13th of October. It's now going to be on the 15th of October. So we have one extra day of lab material to study for that practical exam. If that makes a problem for you, it shouldn't, because you and I are both signed up to be here. But if it makes a personal problem for you, go ahead and email me and let me know what's going on. Any comments about that? Will it work for most of you?
Yeah, everything's cool.
Yes.
Okay.
That was good, Charlie.
Okay. You'll have an extra day then on these muscles, because I'm being a realist. I know a lot of people haven't really begun those muscles yet. Oh, you got a couple down that you always get right, and but not many. I hope to go through quite a few today with you. Okay, but by extending this section for the practicum one session to the 15th, what will that do to the next practicum? Will it crunch it down? Well, of course it will, but I've looked at it. And I know that practicum backwards and forwards. It's the one I construct. And I know we have plenty of time for that one. Okay, so don't worry about that being a problem. Okay. Oh, God. Okay. Don't you love these notifications? I disassembled my landline phone just before we start because I'm tired of all the scam that comes in and all the phone calls that come on when we're busy. Okay, I'm going to share the screen, go to our material.
Hey, Charlie, quick question. So
Yeah.
this is probably stupid, but for the practice test that we just did on the muscles,
Yes.
is that basically exactly what it's going to be on the practicum? Like you just name the muscle, the insertion, the origin?
Okay, let me get signed in first here, okay?
Okay.
I'll answer. Okay, the questions that were asked would all be fair game, but only I think on maybe one or two muscles would you be asked first to name it, and you will always be asked to name the structure or the muscle. There are a couple of structures we haven't talked about yet. But as to whether or not you're going to be asked anything else, you won't probably be asked all the other three: origin, insertion, and action. The most likely one that you'll be asked is the action. Okay. And then the next most likely one that should be asked is the insertion, and then the origin. But, you know, I'm not trying to get you set up to play a game here, which ones are the most important to study. They all are, because every point counts. Okay, so I put that test together thinking, well, how am I going to put the test together when it comes time for the real thing, you know? And I like the question sort of like that. Okay, you'll have another test before then. You'll have another practice test.
Okay, yeah, because I really like how it was like structured. And then Another quick question for, let's say, the arm, like the forearm, on the test, will we be able to see where the hand is? Like if it's a right arm or a left arm, like you'll show us the hand.
I don't think it's necessary to know right or left. You need to know lateral and medial, and radial is on the thumb side, right?
That's what that's what basically.
Yeah, I will have clues for you for that, yes.
Okay, perfect. Thank you.
Anybody else? Okay, we're at week 7. There's a discussion topic here. One is on nursing, and there's a discussion topic also in 110. And the other discussion topic involves the use of animals, raising animals for dissection purposes, and what your feelings are about that. Okay. Chance to vent for some people, other people, not so much. Okay, so there's 2 discussion topics. Okay. And then the weekly assignment is the same in both places. And the weekly assignment, if I popped it open, would tell you to read chapter 24 as we just outlined it. Okay, so that should be good. While I'm here, I moved the condensed muscle list down. I stole it from week 6, the human muscles and the cat muscles. These are the same as you had in week 6. I just pulled them down because we're using them here. Okay, and then there's some additional terms we're going to start on. Okay, the urinary system is our lecture topic. It's also our reading for the week. The urinary system is fascinating, actually, and at first it's got so many ducts and passageways and things that you think, oh no, this is just a maze of material, but it all will come together. Functions of the urinary system. Well, one, of course, elimination of waste. Also, some of that waste has to be stored temporarily, so the storage of urine. And then salt balance. When you have salt balance going with it without having to say it, you have water balance as well. The maintenance of your blood pressure, very important for your kidneys. And general maintenance of homeostasis. Homeostasis, I think I defined it once before, but homeostasis is the status quo of the body when it's in a healthy state. Well, this part here is so simple, and it makes you think the rest is going to be, unfortunately, no. 2 kidneys. The kidneys are retroperitoneal in position. That means they're not in the abdominal cavity. They are on the other side of the visceral peritoneum and between it and the body wall. So, for instance, if I take some putty and call it a kidney and slap it on the wall of this room that I'm in, just slap the putty on there, and then take saran wrap and coat the entire room. The kidney or putty is behind the saran wrap. The saran wrap represents the parietal peritoneum. All the rest of your abdominal pelvic organs are inside the abdomen. They're on the abdominal side of the parietal peritoneum. But the kidney is not. It's protected somewhat from infection by being on the opposite side of the serous membrane, the parietal peritoneum. That's why when anybody has a transplant, kidney. They retrieve or harvest the kidney from somebody's backside, never going into the front. That way you don't even enter into the abdominal pelvic cavity and risk infection. Okay. Besides the two kidneys, which are not at equal heights in the body, the right kidney is lower compared to the left. And that's because of the liver pushing it down. The liver needs space for itself. You have two ureters. These are ducts that conduct urine away from the renal pelvis of the kidney. Now, the renal pelvis is the chamber inside of the kidney where the urine finally collects just before it exits, and it exits through the ureters. These ureters also are retroperitoneal. They're with the kidney behind the parietal peritoneum, but they can't stay there, not if the urine is going to be expelled from the body. So about halfway along the run of a ureter going to the bladder, it pops through our wrapping, our parietal peritoneum, and enters into the abdominal pelvic cavity. The seal is tight. The seal is tight. There's not a transference of bacteria or fluid or anything like that between the two sides. And then the contents of the ureter are brought to the dorsal side of the bladder. The bladder itself is lined with rugae. We saw that in the stomach. And that allows the organ to expand. The tubular passageway to the exterior, we know it as the urethra. Hang on. What's worse, a bladder infection, which is quite common, or a kidney infection?
Kidney.
Yeah, kidney infection, of course. So when the kidney delivers urine to the bladder, it delivers it to the posterior side of the bladder by the two ureters, which remain separate and enter separately into the bladder. The bladder swells up. Now, if you decide, well, this part of the movie is too good, I'm not leaving yet, I'll just hold it as long as I can anyway. The tendency would be for the urine possibly to be pushed back towards the kidney. And any bacteria, such as found in a bladder infection, would go that way towards the kidney as well, and that would be dangerous. So as the bladder expands, because you're not emptying it, it pushes dorsally against the two ureters and pinches them off. I don't know if you've ever waited so long that your kidneys actually hurt, but that's the reason. They're being overinflated. Okay, this next portion on the structure of the kidney, you're not going to be familiar with it just at reading through this. You need your book with you. And you can skip ahead to the diagram that you peek at. Okay. And then we'll go back up and see which ones of these we covered. Okay. Obviously, here's the kidney. Here's the ureter. The ureter doesn't do any absorption. It doesn't do any of those functions of the kidney except to drain it. When we go back into the kidney, although the urine will be coming this way out, in our flow chart here, we'll go back in and we find the renal pelvis. The renal pelvis is the last chamber inside of the kidney that collects all the urine. The next stop after that is the ureter. Urine first is produced by the body of the kidney. We'll be talking about that. I'm not trying to skip anything here. I'd be skipping quite a bit. Urine is produced, and the urine is deposited or brought to this structure here. This is a minor calyx. Now, here's the minor calyx right here. Here's another minor calyx. Here's another minor calyx. Here's another minor calyx. Here's another one. Where two minor calyces come together, like right here or right here, it's called a major calyx. Well, somebody just was being very, very free with labels. I don't see any difference between minor and major calyx, except one is singular, the other is plural. Minor calyx, the urine is deposited, moves towards a major calyx. Then it moves towards the renal pelvis, and then it goes out through the ureter. When we look at the kidney, you can always see on a real kidney a color difference. This is a model, but it has it too. And there's an inner portion here. Basically, what color is that? Anybody?
Where? The blue or like the?
No,
The
no.
burgundy.
Like a burgundy.
Dark red.
Okay, dark red. This is the renal medulla. It's surrounded by the renal cortex. You'll notice that there's a separation in appearance, at least, and by blood vessel between the cortex and the medulla. My arrow's tracing it. In a future, that means another screen here. In a future screen, you'll see that that's called the arcuate artery that separates the renal medulla from the renal cortex. Okay. Well, material has to get into the kidney. If the kidney is going to work on it, to purify it, to detoxify it. And that happens at this area here, where the ureter exits, where the vein, this is a vein, renal vein, exits, and where the renal artery goes in. This indentation on the medial side of the kidney is called the hilus, H-I-L-U-S. It can also be called the hilum. If you've ever seen a bean, especially like a black-eyed pea, with the dark spot on one side, it's always on the concave side. So this is the hilus, not a hard concept there. The blood coming in is the blood that needs to be cleaned. So here's a renal artery coming in, and next it's going to go up between these structures. These structures are called renal pyramids. Renal pyramids. You can count 1, 2, 3, 4, 5, 6, 7 renal pyramids in this model. The normal human body has about 10 or 11. It varies from people to people. They're not truly a pyramid shape. It looks like a pyramid in 2 dimensions, but really it's like candy corn. Okay, you all know candy corn, Halloween coming up. I love candy corn, but it makes you sick quickly, headache. Okay,
Do you eat it
So-
with salted peanuts?
huh?
Do you mix them with salted peanuts?
Salted peanuts.
Yeah, that's what my mom has always done.
Oh, okay.
Salty sweet will do it.
I've never heard of
Have you ever drunk apple juice fast?
that. What?
A glass of apple juice. Have you ever
For
drunk
fast?
it? Have you drunk it fast? Just gulp it down.
I don't think so.
You don't do it. Don't do it.
Oh,
Or,
why?
well, if you're going to ask why, then go ahead and do it.
I'm down.
You'll find.
I'll record it. I'll send it.
Okay. Okay, now look. Here we are with renal pyramids, which are not pyramids. They are like little tops, spinning tops, toy tops. And the best description I can give you is candy corn. Okay, so you get an idea in 3 dimensions what they look like. They do bend backwards into the other portion of the kidney. Okay. The vessels, artery and vein that go between are called the lobar artery and lobar vein. I don't have it pointed to here. In fact, I think we've exhausted this one, so that's good. This is the lobar artery and vein. It's also called the interlobar artery and vein. That is confusing to me too. Okay, but that's the way it is. I think it's safer just to, let's call it lobar artery and vein. Okay. Here we go with the more diagrammatic version. In with the renal artery. Okay. The renal artery takes blood up through the area between renal pyramids. The renal pyramids aren't renal medulla. They are a part of the renal medulla. So this whole area is the renal medulla. And the smaller area out here is the renal cortex. It's bringing blood from the renal artery to the lobar artery, and then it turns and goes across the tops of the renal pyramids and separates the medulla from the cortex. As it goes across the top, look carefully because these diagrams never show it very well until you see a magnified one, which you're going to. The blood goes up into these little tree-like structures. They don't really look like that, but this is where the blood starts its approach to what we call the nephron. And it's the nephron that is the physiological unit of the kidney, and it's the nephron that will filter the blood. Okay, on this diagram, renal pyramids are shown here. You don't have to know any of this outer, inner, and renal papilla. The renal capsule, that's a good term. It's a very thick, fibrous capsule that protects the kidney from damage. This is the renal capsule here. The artery or vein or both that go around and separate the medulla from the cortex are the arcuate vein and artery. It's not hard for anybody to remember this one. They get that word arc in there, A-R-C, and it does look like an arc, so no problem. Interlobular artery. Well, we had lobar artery here, arcuate here. Now the ones that go right up and make the stalk of this tree or trunk of this tree are the interlobular arteries. And there are lots and lots of them. The renal glomerulus you cannot see in this picture. They've got it labeled, but it's wishful thinking. You'll see it in just a moment. Okay, we know renal capsule, renal cortex. You don't need to worry about renal corpuscle. We know renal medulla, minor calyx, major calyx. The segmental artery is not necessary. The renal artery and vein are. The renal pelvis is, and the ureter. Okay, let's go back up now and see how many of those terms we've already caught. And we haven't caught all of them at all. Okay, structure of the kidney. The hilus is the indented portion. The outer portion of the kidney was the cortex. Okay. It contains glomeruli, which we haven't identified yet, but that'll be part of its definition. The medulla is the inner portion. It contains the renal pyramids. The renal pyramids, the candy corn shape, 5 to 11 of these structures in each person. And they contain what are called the loops of Henle. The loops of Henle, you're going to be on very familiar terms with that in just a few seconds. The ureter, the tube that drains the renal pelvis to the bladder. The renal pelvis, the last collecting spot for urine in the kidney. A major calyx is formed when you have 2 or more minor calyces. The minor calyx is the first thing urine enters into in that central cavernous area. It's the very first thing coming from the renal pyramid. The interlobular artery, that was the trunk of the tree that I mentioned just a second ago, way out there in the cortex, and that takes the blood out towards the nephrons. Arcuate artery separates the medulla and the cortex. The lobar arteries and veins go between the renal pyramids. We haven't done afferent, nephron, arterial, or any of this other material just yet. That's part of the nephron.
Charlie, could I ask really quick, where
Yeah.
does the kidney stones form?
They usually form in the renal medulla, the pyramids. I don't like that topic, you know. Do you have things that make you squeamish? It doesn't
No,
make,
but I completely understand.
no, I mean, I don't mind talking about it, but it gets some people squeamish. It gets me that way. I knew a guy, big guy. No, his name was Al Kirsch. You wouldn't know him, so I can say his name. And he was rough, tough, push you around type guy, you know. And he got him. And oh man, that made a crying baby out of him. They're bad news. Okay. Hopefully you can get them taken care of with ultrasound. Okay, we're looking at the kidney right now. This model here, we're going to section a little bit out of the top possibly. Here we sectioned a little bit out of the top. And here is a nephron in the cortex. Medulla down here, cortex up here, and a nephron. This does not even show a nephron up here. It's so small. They're very, very small. you have coming from the interlobular artery. The interlobular artery is the trunk of this structure. It's going to branch out. They're showing it branching 6 ways. The number of branches obviously varies. And each one is going towards the start of a nephron. You first have from the interlobular, you have an afferent arteriole. Afferent arteriole goes up and enters into a ball-shaped structure. Afferent means to have an affinity, a desire to be there, a love for it. So you go for it. The afferent arteriole brings the blood. Here it is, right here, this little thing here, in. To come out a little bit later is the efferent arteriole going out. What's going to happen is that the blood enters into this structure. Now, the structure is spherical. It's called a Bowman's capsule. And I'm sure I've got a better picture in a second. Somebody always tells me to do that. They didn't today. Okay. The Bowman's capsule, think of it as a soccer ball, but much, much smaller, of course. And on a soccer ball, you have panels. They're usually pentagons or hexagons or a combination of the two. Take an X-Acto knife and cut out one panel. Cut out one panel off of your soccer ball. Well, you've ruined your soccer ball. But now you can put your fist and first part of your wrist anyway into the soccer ball. You're the afferent arteriole bringing blood, and it's going in. Okay, it goes in at that point, and inside of there are lots and lots of capillaries, very, very small vessels. Capillaries force the blood to move slower and at a higher blood pressure. If we were, face to face and in a real room and there was a fire alarm and it was deadly serious, I mean, an explosion maybe, how fast could we get out of one of our regular classrooms?
Not very fast.
Well, guess, an hour?
No.
Much faster than that, right? You get out fast. Okay, well, on most of our classrooms, we have only one door in a science building. And at least we'd exit through. And but we'd push and get out of the way and get out of there as quickly as we could if we had to. Well, what if I made, 10 doors? Would it be faster? No, not if they're smaller. What if instead you had to get down on your hands and knees and go through a little doggy door to get out? That would really slow things down. Okay, capillaries are sort of in that league. They slow things down. The blood moves more slowly and under higher pressure in a capillary. Moving slowly is good if you want gas exchange, if you want nutrient exchange or absorption, or hormones to be delivered. The slower movement at the capillaries is important. But the pressure builds up. And the afferent arteriole and the interlobular artery are bringing more blood all the time. Get out of the way. Get out of the way. It's like trying to push somebody out of the doorway so you can get through. Okay. Well, there's pressure building up. And what happens, that pressure has to be relieved. Some of it's relieved by the blood exiting from the efferent arteriole. But that's blood that never got processed by the kidney. It just made a peekaboo appearance and then it's back and gone. But when the pressure builds up, you can squeeze the capillaries essentially like a sponge and press plasma out. Plasma leaks out. It goes into the Bowman's capsule and then out this tube here. This is the proximal convoluted tubule. I have a better picture in a moment. And then it flows down the descending loop of Henle and up the ascending loop of Henle to the distal convoluted tubule. And all the time it's moving, the plasma is moving through here. It's having toxic material, nitrogenous wastes primarily, being removed. Now there's some good material in this plasma too, and that's being retrieved. This effort arteriole, the one that didn't move into the tubules, now spreads out, and I guess this is a baby blue or something, and it surrounds the loop of Henle, and it absorbs by dialysis. It absorbs back good material. Crap, bad material, nitrogenous waste, urea, go forward in the tubules until they reach what's called a collecting duct. And then there's no more action upon them except to move them from the collecting duct to the minor calyx. And from the minor to the major, to the renal pelvis, to the ureter, to the bladder and out. The vessels that originated from the effort arteriole and fanned out over the loop of Henle are called the vasa recta. That's a set of capillaries. This is one of the two places in the body where blood that leaves the heart goes through two sets of capillaries before it gets back to the heart. The blood leaving the heart is right now at my pointer, and it hits a set of capillaries in here. I didn't give it a name yet. It's called the glomerulus. That's a set of capillaries. The second set of capillaries is the vasa recta. Okay, there's a summary of the blood flow to and through the kidney. This is text I wrote, but of course I don't even remember what I write, so it's best for me to read it and then find any part that needs explaining. Blood that contains both nutrients and waste. Any of your blood has waste in it right now. It enters the kidney through the renal artery. This takes place at the hilum or hilus of the kidney, which is always on the medial side of the kidney. So the blood goes into the medial side of the kidney. Then once it's inside of the kidney, it branches into a few lobar arteries, and they pass by the renal pyramids. Once this blood still unacted upon, once this blood reaches the cortex, it turns and splits the medulla and the cortex at the arcuate arteries, and it travels between the medulla and the cortex. Then you have interlobular arteries. These are also called cortical radiate in case you come across it. I tend to like the term interlobular myself. Okay. These split from the arcuate arteries and head into the cortex where the nephrons will soon start. These are what I refer to as the trunks of the trees, trunks of the little trees, the interlobular arteries. When blood leaves the interlobular arteries, they go into smaller afferent arterioles. Afferent meaning having an affinity or love for or desire to be with the Bowman's capsule. These travel to the start of the nephron and enter Bowman's capsule. Once inside the capsule, these can split up many times into a capillary network or ball called the glomerulus. The pressure is high and it causes some of the non-formed elements, meaning fluid elements, meaning plasma, causes plasma to be pushed across the glomerular wall. That means across the capillaries that make up the glomerulus, and into a space right around it, still contained by the Bowman's capsule. Then this material moves into the proximal convoluted tubule. Why does it move? Does it swim? No, of course not. More material, more fluid, more plasma is coming all of the time. All of the time, material is going through the glomerulus. When they want to see how well your kidneys are doing, they have a test, and it measures more mathematically than anything else your glomerular flow rate. And as you get older, it gets slower. If it gets too slow, well, then you're like that woman on Prop 23 in the dialysis commercial. Okay. From the proximal convoluted tubule, and it's convoluted because it twists a bit, a thicker plasma now moves into the loop of Henle. There's a descending portion, the actual loop, and then the ascending portion of the loop of Henle. Anything that reaches the end of the loop of Henle enters into the distal convoluted tubule, and from there to a collecting duct. The collecting duct is shared by many nephrons. A nephron runs from Bowman's capsule until you get to its collecting duct. That's a nephron. That's stated right here. The capillary network that retrieves good material so we don't waste everything from the plasma that's moving through the loop of Henle. That capillary bed is called the vasa recta. Okay. Now, I added some more photos. That's all you need. But some of these are a little bit better. Some of them aren't as good in some respects. But when you look at 2 or 3 different ones, you put it all together. Okay, I'll go fast where we can. Ureter, renal pelvis, major calyx, minor calyx, the renal artery. This is a lobar artery. This is an arcuate artery and vein. This is the medulla in here. The cortex is out here. Here's the, coming off the arcuate, the interlobular artery. Each one of these little knobs is to represent a Bowman's capsule. Okay. Blue for vein, and this red for an artery. This is out in the cortex. This is out in the cortex. Here is a lobar artery right here, and a lobar vein. Actually, this part would be in the medulla because here's the arcuate vein, and that would mark the difference between the medulla below it and cortex above. Okay, here's the arcuate artery, starting again, lobar to arcuate, and then this one is the interlobular, and then it breaks off to smaller afferent arterioles. The afferent arterioles go over to the glomerulus, which is inside of Bowman's capsule. Okay, Bowman's capsule is shown here, I think in what, a lime green? Bowman's capsule. The glomerulus is the set of capillaries being fed by the afferent arteriole. The pressure develops inside of there, forces plasma into the proximal convoluted tubule. Down the descending loop of Henle, where all the dialysis occurs. The loop of Henle, the ascending loop of Henle, and then the distal convoluted tubule, not quite as convoluted, going across and reaching a collecting duct. The efferent arteriole, leaving Bowman's capsules here, fans out, and the capillaries that it forms retrieve valuable material from the loop of Henle. This fanned out area of what we call peritubular tubules is also known, and we will call it the vasorecta. Okay. I don't know if you do this too. When I gave you that one discussion question on the bones, you look around for the one that you like the best, but there's always something about it you don't like. So you keep looking and keep looking. I'm going to have to just take one here. Okay. This is a nephron. A little bit different representation than I showed you. Okay, but that's okay. Here's the afferent arteriole. That's bringing blood into Bowman's capsule, which is here. The blood that gets inside of Bowman's capsule fans out into a glomerulus, a capillary bed, and some leaves by the efferent arteriole. But under pressure, plasma is pressed out into the proximal convoluted tubule. Then we have the parts of the loop of Henle, and then we have the distal convoluted tubule and the collecting duct. It isn't urine until it gets to the collecting duct, because there still is some activity going on in the distal convoluted tubule with respects to the reabsorption of water. The vasorecta shows in this one nicely. The efferent arteriole fans out in the darker vessels here, and that becomes the vasorecta. Okay. Okay, your discussion topics here. The one I chose for the entire class is the one on dissection. I figured it's more appropriate for everybody. The one I chose for the 110 class was on careers. If any of you would care to forward a discussion question that you'd like to see people get engaged in, I'd be happy, to have the help. I'm just trying to think up things that I'm interested in, and I'm not sure if you are or not. Okay, thank you, Ryan. Hmm. Okay, are you still seeing my cursor up on the chin?
Just seeing you and everyone else. So
Okay,
no screen sharing. As of
okay,
yet.
well, we'll get that. Was afraid if I undid it, that would happen. Are you seeing the cursor now?
Yes.
Okay. Okay, here's where we were. Mylohyoideus, digastricus on both sides. This one, 25, we can hit it right now. You're going to, of course, have your own method, I'm sure, for learning the origins, insertions, and functions. I'll often mention what they are as I go along, but may not be the way you want to do it. So uh, uh, if I don't mention every one, that's just as well. This one here is the sternohyoideus. It runs from the sternum to the hyoid bone. So some of the muscles are easy to remember because of their name. They just tell you what they, where they are. Others are easy to remember because they tell you what they do. And others aren't easy to remember at all. And this large muscle here is running from the sternum to the mastoid process. There would be another one on the other side. And that gives that typical V that we see under our chin. This is the sternomastoideus. Sternomastoideus. If you had both of them present, you would use them to bring your head down. If you work just one of them, you could just tilt your head to one side or the other. These muscles, okay, these two, the right and left one, can work synergistically to lower the head or antagonistically, one tilting to the right and one tilting to the left. Okay. I want to do the same muscles with the cat. in order to make these links work, in case I didn't mention it to you, sometimes they just do on some browsers, but if they don't work for you, be sure to just pop it out right at the top there. Okay, now the same muscle, starting with number 22 on the cat. You need to do the double click on here to get the bigger view. Okay. Here's the cat's masseter. Instead of being a strap-like muscle, it's a rounded, almost ball-shaped muscle. Okay. This muscle here, if we do it numerically, 23 is next. This is the mylohyoides. You remember just a moment ago. And it was in between, on the human, the two digastricus muscles. And here they are. A little bit more fur would have been nice to have been taken off here. And here, 25, is the sternohyoides. The hyoid bone is roughly right here. It is not the purple looking material. That's the transverse jugular. We'll be learning in the next section. But here it is going straight up. You can see a little bit of the sternomastoid, but it shows better in the next slide. Have you ever said something you didn't mean to? I mean, you didn't realize the consequences of saying it, or you didn't mean it the way everybody else took it?
Yes.
Well, I'm glad I'm not a rookie, you know, because I'd have to watch my step if I were a first year full-time instructor. I'd have to watch my step all of the time. You know, you see people, they get fired because they said something and they didn't really mean to say it, or they were brought up in a household where it was common to say it and they haven't shaken the habit yet, but we're going to hold them accountable for it anyway. And but sometimes people say things that are outright mean, yes, and that's not correct. But I've said a few things that could have gotten me into trouble. Never have, however, and it's lucky. One has to do with these two muscles. They're the same. They're the digastrics. When we used to teach over at the science math building, the old building, we had cats, and they had pretty good muscles except the digastrics. The digastrics were always severely underdeveloped. You could almost peel them off like a piece of tissue paper. We really almost just skipped them most of the time. And that was disappointing, but you know, that's something you have to live with. But we got one set of cats one time, and I wasn't expecting this. The cats were being dissected. We finally got to this area, and these two girls were working together. Now, see, I'm not supposed to say girls. I know it. You don't have to remind me, and I'm going to say it anyway. I don't want to say ma'am or ladies. God, that's so restrictive. Anyhow, they were dissecting, and the one girl who was actually with the tools in her hand had one of these probes that you can see right here, and had one for each of these two muscles, and was lifting both of them up at the same time. You know, I don't think she realized that she probably was the first one in that building that ever saw these, at least that well. I'm walking by, and I'm on the other side of the lab bench, And I'm looking at what she's doing, and she's lifting these two muscles up. And I go to myself, my God, those are great, you know? Oh, I couldn't believe it. I couldn't believe we actually had really good digastric muscles. I also didn't notice, because I honestly don't notice these things. Now you say, sure, Charlie. Well, yeah, I'll say it. You believe it or you don't. She was leaning over the table to do this, and part of her anatomy was showing. I think people call it being well endowed or something like that. And that's a part of the anatomy that is of no interest to me, you know. And I looked at her cat. She's lifting those two digastrics up, and I said what came to my mind. I said, "Wow, you got big ones." And oh God, she she stood straight up. Her lab partner stood straight up. They thought I was referring to the anatomical thing, but we all knew what we did. It was fine. Okay. Okay, I'm getting a message for some reason. Are you hearing me?
Yeah.
Yep.
Okay. Oh, okay. I just got a little message thing. I don't know what it means, so as long as you can hear me, we're fine. Okay, here's muscle number 26. This is the sternomastoid. Now, this, although it's blurry, this was the sternohyoid, mylohyoid, digastric, and way up here, the masseter, and this is the sternomastoid. I'm back to human muscles again. And I'm going to take you down to number 30. This model has seen better days, but we have plenty other ones to look at too. Muscle number 27, it's a long, flat muscle. It extends downward from the serratus anterior. This is the external oblique muscle, helps to compress the abdominal contents and twist the thigh. The striations in the external oblique run from lateral to medial in a downward direction. That's important to be sure to keep them straight. From lateral to medial. Okay. This area here is unlabeled right now. We're going to do it, however. It's a linea alba. The linea alba meaning the white line. It covers, in this case, the rectus abdominis muscle. The rectus abdominis is uncovered over on this side. 28 is the internal oblique. In the internal oblique, the striations run lateral to medial, but they go upward. And then we have transverse abdominis, 29, that go roughly straight across. It's very difficult to see where 28 and 29 separate from each other. So we don't ask you to do that. I can't do it either. Here's our rectus abdominis, number 30. There's very, very little of the external oblique showing in this model because of the way it's oriented, but that's it right there. Now, this keeps going to the same picture because being not wasteful, use the same picture for 3 muscles. Why not? On the cat muscle, here's the external oblique. It's huge. This rolled back portion here, this was the latissimus dorsi. Latissimus dorsi. Underneath the latissimus dorsi, you can even see the serratus anterior to the first 8 ribs. You can also okay, that's a really good external oblique. Here's the internal oblique. On the internal oblique, you'll notice the striations are running upward. The midline is right here. The internal oblique runs this way. And here, number 29, the person managed to get some transverse abdominis showing. It's usually quite thin, not well developed in anybody. 30 doesn't look like it did a moment ago on the model. It's because of the orientation that this picture was taken at. This is the rectus abdominis running here. I would never ask you a question like that. I would have it shown properly. If this is the rectus abdominis though, and this is the transverse abdominis, and this is the internal oblique, where's the external oblique? Folded back right here. Okay, that's where I'm going to stop on showing muscles. I want to show one more page. We'll have it. It's a page called additional terms. I don't want to just stick it there and you wonder what it's for. Additional terms that are not on the cat or human muscle sheets. Or if they are, they're not presented the way they are here on the additional terms. If you happen to have already printed this for yourself, you might want to print it again. I cleaned